Dobro večer, ja sam Vesna, ne iz Ripe, iz Ripe. And the talk title is mouthful, but it's actually about three things. What's the difference between RIPE and RIPE NCC, the IPv6, and RIPE Atlas.
And you made it.
Okay.
Wow.
Wow.
That's
So,
a large labor. Careful with it.
yeah. So I was here already last year talking about RIPE Atlas unofficially, and this is now the official presentation. The similar talk I already did at FOSDEM this year, and I had there 1 hour, and here it's a little bit shorter. So and in the meantime I added extra slides. So so it's going to be even faster. And then the appendices, I will not even go through them, but the slides will be online, so you'll get all this. So, how many of you already know the difference between RIPE and RIPE NCC? 1, 2, yeah, a few. So, for the people in the back, the RIPE is different from RIPE NCC. So, RIPE is a community of the network operators. So you are all part of RIPE if you want to be. And RIPE was there first. So it was like a group of people who wanted to deploy IP networks in Europe, and they started getting together in the physical meetings and talking about each other, like how are they going to interconnect those networks. And then they had the database, the WHOIS database, where they recorded their contact details and their network numbers and so on. And 3 years after that, they created a not-for-profit organization in Amsterdam called RIPE NCC, so Network Coordination Center for the RIPE community. And today, RIPE NCC is actually present in 3 locations. It's in Amsterdam, in Middle East, and in Russia. Those other offices, one is in Dubai, and the one in Russia, it's still not even incorporated, but we have colleagues there. So, RIPE community, we don't know how many people are there because there is no official membership. So anybody can take part in the RIPE community, mostly in the mailing lists, and there are also 2 physical meetings per year. RIPE NCC, on the other hand, has about 130 employees. Most of us are sitting in Amsterdam and flying around, and we implement the policies that were decided by the RIPE community. So we have members, we are the registered legal organization in Amsterdam, and so that is the difference. So whenever you want to actually say that you have talked with somebody from RIPE NCC, you cannot really talk with somebody from RIPE because, yeah, that's just anybody. Okay, so that was the first thing. RIPE NCC is one of the 5 regional internet registries, or RIRs. And the other 4 you can see here on this picture. I have to go quickly. And what we do mostly is distribute IP addresses. So IPv4, IPv6, AS numbers, and then we do a lot of other services. The reason why we do those other services is that we coordinate the work of the internet service providers in our service region as a neutral and impartial organization that is trusted by all of them to coordinate the work in which they all have a stake in, but they are competitors to each other, so they wouldn't trust one of them to do that, but then they trust a third party. And then, so RIPE NCC has several other things, for example, running the K-root name server and CCTLDs or secondary CCTLDs for a lot of countries and so on. And for me, very important, the measurement services. So that's what I will be talking about later on. So we also travel around and go to all kinds of meetings like this. And in this region, there are several other conferences coming up. The most important one, which is organized by RIPE NCC, is next year in April in Belgrade. So that's Southeastern European meeting, because we can't call it Balkans because that's not politically correct, so we had to come up with this like long acronym. And yeah, this recording is Very nice. And you're all welcome to come to that meeting because it's not only for the members of the RIPE NCC. And the meeting is sponsored by RIPE NCC, so it's free attendance. And there are lectures by the mostly local community and then also from the rest of the RIPE community that we managed to attract to come to these meetings. So it's the fourth one. There was one in Dubrovnik, in Skopje, in Sofia, and the next one will be in Belgrade. The RIPE meetings are also open for everybody, but you generally have to pay for them. So they last for a week. And they are mostly happening in Amsterdam, but also in other cities. And the people who go there are mostly, more or less the same people. So we are trying to attract younger audience, younger participants, and mostly the students of technical studies, of the things that are related to the topics of RIPE. And so we have started the RIPE Academic Cooperation Initiative, in which we sponsor 5 students to come to the RIPE meeting and present their work, meet the actual engineers and the network operators that will be using their work in few years, and to get a very valuable feedback about their research or whatever they are studying. So if you are a student, PhD or any other kind of student, do submit your work, and maybe you get selected to go to London, or the one after in the 2015 is in Amsterdam. So any questions until now? Okay, if you do have a question, either raise your hand and maybe I'll see you, or just shout. So originally, I just wanted to say, and this is how you get IPv6 addresses, but then while I was giving out these stickers, somebody said, what is this IPv6? And I was like, okay, maybe I need to explain that too. So I thought, well, by now everybody knows it. And why do we even need it? So there is a very big reason why we need IPv6, and that's there is no more v4. So in 2012, RIPE NCC ran out of unlimited numbers of IPv4 addresses that you can get if you need them. Now you can only get 1,000 IPv4 addresses if you are a member of the RIPE NCC. So that's it. And the most often asked question during the IPv6 talks is, how can I get more IPv4 addresses? So you can't get them from RIPE NCC anymore. You can get them from other members of the RIPE NCC who have them somewhere stashed. And they are willing to transfer them to you. And RIPE NCC is keeping track of those transfers. So we have the so-called listing service where you can list the ranges that you are willing to transfer to somebody else, and you can also say, well, I'm looking for so many IPv4 addresses, and then we are kind of putting you in touch with each other, and there are procedures for those transfers and registering those addresses and so on. So that's the way how to get more than 1,000 addresses that you can get from RIPE NCC now. But none of that matters, because you should not want v4 addresses anymore. You should all move to IPv6. Why? Well, because it's wonderful, and it's going to last us for forever, right? That's what we thought for v4 also. And so these are some of the basics. So RIPE NCC actually gives training courses in IPv6. So you can download the course material. Since recently we also have the advanced IPv6 course, which is multiple days, and it's really technical and hands-on. And the other one we now call basic, and so it's like 1-day course. And so these are the basics of IPv6 addressing. So the addresses are just much longer, and they're written differently with colons and hexadecimals, and so every interface can have multiple addresses. And the main problem with IPv6 is that once you have v6 network, it cannot talk with v4 network. You need translation technology. So for the next how many years we will need these translation technologies for the new internet to talk with all the internet. So it's a lot of business for the network operators, so be quick to learn IPv6 and you'll have a job for the next 10 years. So we give this subnetting card, and I distributed several already. They're all gone now, so you can download them from our website. And this is like a really handy overview of how does the V6 networking differ from V4 networking. So in V4 we went to the classless addressing or CIDR, so you could actually have like the network of any size. And in V6 we are back to kind of half classful addressing, in which we say, well, it can be any size as long as the last 64 bits are not considered for networking. So the last 64 bits is for the addressing within the subnet. So every subnet has to be /64 or larger. Okay, so that's like a very important thing. And then the rest is kind of important when you are going to make addressing plan and whatever. But there is much more information in the appendices. So this was really, really quick basics. Like, why do you want V6? Because there's no more V4. How do you get V6? It's really easy. So you get it from your friendly RIR, which is RIPE NCC in this region, and you can get a very large allocation, or even larger if you say, well, this is not enough. So the minimum allocation size is /32, but if you ask for /29, we will also give you /29. And from that, if you are a member of the RIPE NCC, then you can make assignments to yourself and to your customers, the end users. And the end users can also ask for the provider independent assignment. And when we run out of one block that we have, this one, we ask for more from IANA, and then they also give big chunks to other regional registries. Okay? So to qualify for the allocation, you just have to say, I would like to have one. Okay? And to qualify for the provider independent assignment, that's a little bit more complicated. So yeah, there are several of the things here. I'm going through this very fast because a lot of people here are not providers. So most of the courses that we normally give are for the members of the RIPE NCC. But if you're not a member of the RIPE NCC, this is much more important. So how can you actually start working with IPv6 if your provider is not giving you addresses? Well, you can use the unique local addresses. So this ULA acronym stands for unique local addresses, which is kind of private IPv6 space. So you're not supposed to route this on the internet. But then you use some kind of translation and then it works. If you want to test IPv6, there are a lot of tunnel providers, tunnel brokers that will give you an IPv6 range and then you can just test it. Or you should ask your upstream provider, and they will of course say, really, IPv6, nobody ever asked for that before. Well, that's not true. So, you know, tell your friend to also ask for IPv6, and then they will also tell him, you know, like, oh, really, you're the first one to ask. No, you're not the first one to ask. Some security considerations, since we are on the security conference, and yeah, the IPv6 networking is still being in development because not many people are using it, so these security practices are not like developed yet, so there is still a lot to be done there. And then we also measure how ready are the members of the RIPE NCC, and so we look into you know, the numbers per country, or how many of these LIRs asked for the allocation and how far did they get with deploying V6 by just looking at their administrative steps, like did they set up reverse DNS, did they register the route object, did they announce their prefix, And that was for a long time the 4-star IPv6 ripeness. So it doesn't matter, if they never did a ping from their address space. If they announce it, that's fine. They have 4 stars and then they get a t-shirt. And you would be surprised how far in encouraging the deployment of IPv6 the free t-shirt goes. So we actually encouraged a lot of people to at least do these 4 steps so that they can be listed on our webpage and get a t-shirt. So we have these web pages in which we actually list every LIR per country that has 4 stars. And I didn't put it here because there is quite a few. There's 13 LIRs in Serbia that have 4 stars. And we've been doing this for a long time, and people said, but that's not really any measurement. That doesn't mean that they're doing V6, so why don't you start measuring if they're actually doing V6? So we did, and that is now called the 5th star of IPv6 ripeness. And you can see on this URL who they are. So we do different kind of measurements for the access providers and content providers. And these are the only 3 in Serbia that actually got the 5th star. So is there anybody from one of those providers in the room today?
I used to work for the second one.
Woo. Okay. Okay, you can claim your t-shirt later on. Okay, good. Yeah, even better. So that's how it works, and if you do manage to get 4 or 5 stars in the future, you can write to ncc@ripe.net and then we will ship you the t-shirt. So we don't always have to travel around and carry them. So we provide these pie charts for every country, and then we also do this kind of bar graph to show how far the countries are and so on, because countries actually like to compete. And that's also a lot of encouragement, when we go to the internet governance forums and we go where's your country here? And they go oh my God, we are doing worse than, whatever, San Marino. And then they go who do we have to talk to increase this? And, they, for a very, very long time, Slovenia was on the top. Slovenia was really, really the best. But then other countries took over. Okay, that was the short story about IPv6. Questions?
Can I have some IPv4?
The cherry on top, no.
One question.
Yeah.
Will there be restrictions about dynamic and static address now when we have IPv6? Because ISPs give to regular user only dynamic address. So will there be some legislation involved where ISP will be forced to give the static IP, or it will be still giving the dynamic one?
Yeah, that's an interesting question. The thing is that the policies for address space distribution are decided by the community. So, and then they're also implemented by the community. So then the RIPE NCC, even if there would be such a regulation, as you call it, we wouldn't be able to enforce it. So in the end, it is up to the provider to decide how do they want to deal with their own address space, and it's up to the customer to then stay with that provider or go to another provider. And as it is now, currently, the recommendations for making customer assignments in IPv6 is to assign to every home user either /48 or /56. So my provider in Holland, Access for All, they were giving out to their home users at the beginning, so that was 2008, something, 7/48. So I have at home 65,000 subnets, and each subnet is /64. So in each subnet, I have 64 bits to like number my printers and so the current recommendation is that the providers should give the static /48 to their customers, and then for the home users it should be this, or if they are really like a little bit worried about like they have zillions of customers or whatever, they should give to every customer at least /56, so that you can at your home do the subnetting and have at least 256 subnets, so that your guest network is separate from your kitchen network where you have your printer and your fridge and coffee machine, whatever, and from your living room network or whatever. Because we don't know how is this the networking going to develop in the future, and we don't want to limit ourselves now by giving to every end user one subnet, and then a provider has to in the future renumber everything. So we go like, now we are kind of trying to make mistakes on the side of not being conservative. So with IPv6, there shouldn't be any address space conservation constraints in giving customers static addresses. So there is no reason for them to give you dynamic addresses, and maybe technically it's not even possible. However, there are some countries in which legislation actually is making providers to like not being able to track their customers by the static prefix that they give to them, so they have to cycle them through the prefixes or whatever, like some kind of weird thing in which they're trying to implement the law through these technical means, but I'm not sure if that's like that in Serbia. Okay? So I don't really have time here, but I'm sure I have to move on. So now the next topic, RIPE Atlas. So we are deploying IPv6, and we are trying to encourage IPv6 deployment, and then we also need to measure the IPv6 deployment and all kinds of other characteristics. And not only for IPv6, we wanted to develop the global measurement network. And RIPE NCC is in this unique position where we have trust from our community of the operators to operate such a large network. So we developed several years ago an idea to have the community sponsored and community participation in this huge measurement network, and it was called RIPE Atlas because the result was supposed to be the maps of the internet, so the internet traffic maps. This is one of them. So this is just a map of where are the probes deployed currently, and there is 6,600 something active probes at any given moment currently. So there is many more probes distributed, but these are their locations, and you can see that most of them are in Europe because that's where we have most of our members. Then in the States, because a lot of other companies like have heard about it and they are deploying it there, and we are trying to actually have it everywhere globally because it's in benefit of everybody that those probes are distributed around the world, even if your network is in Europe. So this is the definition of it. So the measurement platform for active measurements. We want to provide a view of internet reachability, and it is achieved by such small hardware probes that are hosted by people like you, by volunteers. So once you get one of these probes from us, so they are distributed for free, once you plug it in, it starts doing the pings and trace routes and DNS lookups towards critical internet infrastructure, which we consider to be the root name servers. So the built-in measurements 24/7 automatically done from each of those probes that you saw on the picture are towards all the root name servers. And then we collect that data and put it on maps. You can also get access to the data. It's publicly available. So these are some of the internet traffic maps, and it's just a screenshot. I won't go into all of them right now, but you can browse them and see all the details. And each one of them has many, many options, like IPv4, IPv6, which root name server, which region, like you can really drill down to all kinds of details. And so we have a lot of probes, we have a lot of users. There are these types of measurements, and of course it can be used for IPv6. So how can you take part? Well, you can get one of the probes today or tomorrow from me. You can apply on the Atlas website, and then we are going to ship it to you. And why would you do that? Well, apart from those built-in measurements, the first reason is like you would be helping to gather data about the performance of the internet. Also, once you register as a user of one of these probes, then you can ask any of those other probes to perform the measurements for you. So then you can say, I want a measurement from 200 probes in France towards a server of my interest in Japan. And then those probes will start doing measurements, and that data will be visible to you, and it will also be visible to everybody else. So you are like satisfying one of your needs, but other people also get that data. And we went through different probes. In the past they looked like this, and now we are using this modified TP-Link. It is not a wireless router anymore, and it just does the same thing as the old small probe that we used to have before. In addition to that, we also have larger boxes which are hosted closer to the core of the network, and they're called RIPE Atlas anchors. So we have a few people here that are actually hosts of those anchors, and thank you for that, because those anchors are not for free. Those you have to buy yourself. So the anchors can do more measurements because they're bigger machines, and also because they're placed in the locations that have larger bandwidth available. But because they are stable, and because they're bigger and we can install other software on them also, they also serve as targets. So we run some services on them, and then we do the mesh measurement between all the anchors, and so each anchor is measured by another 70 anchors, and then each anchor is also measured by another 200 to 300 probes. So then you get this kind of gravitational measurements, let's say, that show you the regional baseline. So if you buy that anchor and put it in your network, then we will do all these measurements towards you, and then you also earn extra credits. I will talk about credits later, so you can do extra measurements anyway. So we will choose those 200 probes, but maybe they're randomly chosen, maybe you don't have interest in those. You can choose any other ones and then do the measurements either towards yourself or towards anything else. And actually, well, Balkans, actually the only one currently still in Balkans is the one in Belgrade, in the Serbian Open Exchange, and that's only because I have smuggled it in the suitcase when I was going there to the conference, because like importing the equipment to one of these countries is like really, really difficult. So that's also why we don't have many in Russia or anywhere in Eastern Europe. Our distributor is in Belgium, and he says like he can ship it everywhere, but yeah. You can buy this box anywhere. Like you don't have to buy it from that guy. He just like made a good deal for us. But you can buy components and put it together. We have instructions. How does it all work, and you can do it yourself, or you can. But then it won't come with this little etched logo thing on there. Oh, and neither will it come with. Sorry, where are the photos? Oh no, it's not here. Anyway. Okay, so that was the anchors, and now you can see like where are these probes in every country, and this is the picture of the probes in Serbia, which is not a very pretty picture. So I'm here to remind you that if you got a probe from me last year, or if you got one on some other conference like in Skopje, Dubrovnik, or whatever, do plug it in. It only works if it's plugged in. So all the red ones, look, the red ones are disconnected, maybe just currently, maybe there is power outage or whatever, at the moment when I took this screenshot, which was like yesterday. And the gray ones are abandoned. I don't even see them here, but there is 12 of them. And I looked into my documentation, and I kind of grayed out the email addresses of these people, but here are their names. So if you got, yeah, if you did get a probe from me last year at Balcon, what happened to it? Like, and then you see, well, there's this one which is online. They plugged it in, but they didn't actually register it. So you have to, both plug it in and claim it. Otherwise, you can't do much with it. And then it also looks bad for me, like, so do it.
Your friends.
Yeah, my friends. So this is, I will talk about that later, but this is maybe also a good moment to say it. We also distribute the probes through other people, so ambassadors. So there are people who like the project and they say, oh, I travel a lot and I can take 10 probes to Malaysia, I can take 3 probes to Brazil, and then we give them those probes and they get a nice web interface in which they can track the probes, like who did they give it to, when, and is it online or not. And so, it should look better than this. Okay, so what else can RIPE Atlas do for you? Like if you got the probe and like you actually plug it in, there is a lot of visualizations that we do, and then we also do improvements on API so that you can do your own visualizations. So this is the overview, and this is how it looks like. So the stacked ping graph, which gives you a great view in one graph of where is the problem. Like if everybody has a problem at a certain time, well, then it's a problem of the target. And if, it's just like this probe has a problem, well, it's a problem of that probe. And here is a lot of other options that you can tweak and make this seismograph do wonderful things for you. And we also wrote a user guide. Every anchor mesh measurement is using this for visualization, but any other multiple ping measurements you can visualize this way. And for your own probe, you get like the traffic graph like this, and also every ping measurement has this kind of zoomable ping graph that you can, like select here, and it's going to show you more details and whatever. Like it's really nice. And what are the other people using the RIPE Atlas platform for? Well, either they are the operators, or most likely they are academics. So, for example, Wikimedia was asking us, like, how does it look like from all the probes? Where are those probes going in their CDN? So they have a presence apparently in Europe, in San Francisco, and then so a lot of European probes are going to Europe, American probes and like Asian probes from Japan were going to San Francisco. I think they also have presence here, but all the other probes, they had a very, very long latency. So this helped them analyze, like, where should they put another POP? So other operators use it for that purpose too. Then somebody also had like a case when their customer said, I can't reach your server, there is some kind of problem. So they scheduled the measurement and they found out that one of their upstream providers was indeed having problems. So they switched to the backup provider and they solved it that way. So they wrote an article about it. You can see how they did all those steps and how did Atlas help them in diagnosing this. And then we also do the analysis of different outages, and the most recent one was the Time Warner cable, and you could see some of those probes just stopped reporting for a while. And then the other thing, for example, when the Open Exchange in Belgrade installed the L route, they could see that the latency dropped from 50 to 5 milliseconds. So when the probes in Belgrade started querying the local instance, they could see the improvement like on the probes, and they could then, you know, show those engineers, they could go to the management and say, look, actually did pay off to install L instance here, because now the latency will actually be smaller, not because I just say so, but because RIPE Atlas actually noticed this, and all kinds of other things. I can come back to this if I have time. So, the security aspect. So somebody was also asking, well, what does it actually do when I put this on my network? So what it does is it creates reverse SSH tunnel to connect to our infrastructure. So when you have a probe and you want to do a measurement from his probe, you don't talk directly to his probe. You tell us, I would like to schedule a measurement from his probe, and then when his probe calls home, we say, oh yeah, there are some ping measurements waiting for you, and would you ping that and that target? And then when we get results, we show the results to you. So it all somehow goes through us, and if you do find that some of our practices are not as secure as we would like them to, please report them to us, and then we are going to publish them on this link. And if you go there, you'll see that already happened. Some friendly hackers showed us, you know, how far could they get in using the probes in the inappropriate ways. And they first told it to us, and then we fixed it, and then we thanked them, and yeah. So I hope you will do the same. So they work behind NAT, they work behind double NAT, they of course support IPv6, and yeah, there are no passive measurements. We published the measurement source code, so you can download it, there will be a link later on.
Do they self-update?
Yeah, they self-update. If you ever have a problem, the most usual problem is with this additional USB stick. So just take it out, put it in again, and like the probe will reboot, and hopefully that's going to solve it.
There you go. That's the TP-Link stuff.
Yeah, well, it's either TP-Links or the USB, but yeah, the moving parts. So I also started several years ago, when I started being a community builder for RIPE Atlas, I was like, well, I know a lot of people at hackerspaces, so I think it would be nice if they put probes at hackerspaces. So I was giving them out at CCC Congress and when I was traveling, and then somebody at hackerspaces.org created this other application in which you can say, my hackerspace has a probe, and then it will show up on this map. So that's really cute. Okay, more questions?
Is it possible to reconfigure an anchor after it is installed?
Yeah, but it will be then down for the time that you're reconfiguring it.
No, you have to reconfigure it. I don't have access to it.
Oh, yeah. Yeah, it is possible. We'll talk later. So, which measurements can you do? You can do, as I said, pings, traceroute, DNS, SSL. In the documentation, it says that HTTP measurements also exist, but they're not allowed for the mere mortals. We can do them if you have a very, very good story to like persuade us that we should do HTTP measurement for you. Some researchers do that, and they publish results and papers, and that's really nice. But we don't allow yet the HTTP measurements. So you can do it through the web interface, or you can use API. And through the web interface, how do you do that? Well, these are the steps. You have to have an account, you go there, choose either the measurement that will be repeated or the one-off, and later you can see the results also through the web interface, or you can download the results and then analyze them. It's JSON, and then there are all kinds of tools for analyzing the results. So it's not for free. To do the measurements, you have to spend credits. And to earn credits, you need to host a probe, or you need to know somebody at RIPE NCC who will transfer you the credits, and or like you can transfer credits between users. So as long as your probe is connected, you earn 21,000 credits every day. Oh yeah, this I forgot to put on the slides. The new probe host, so if you get one from me now, you go home, you plug it in and register it, you get 50,000 credits immediately. So you don't have to wait until your probe has been running for a few days. You can immediately start doing measurements. So the pings, so for example, one ping is 10 credits. So if you say, well, I want a ping from 500 probes and it should be running every 3 minutes, then you can calculate more or less how many credits is that going to be. And the system will tell you you don't have enough credits, so like if it is too much. And there is also daily limit, so you can't like overload the system. If you want to create measurements using the API, first you have to create an API key. And if you want extra credits, you can become a sponsor of the RIPE Atlas, and then you earn additional credits for every probe that you sponsor. If you are hosting an anchor, you earn 10 times more credits. If you're a member of the RIPE NCC, you can get 1 million credits for free every month by clicking in the LI portal saying, give me 1 million credits. So, why would you even do it? Well, this is one of the most important and interesting use cases, and it's actually quite simple. So it's the plugin for your existing monitoring system. So you can schedule a ping measurement, and then you can go to this special URL, which is only showing you the status of the summary of those ping measurements. And then you can specify the thresholds, like you can say, well, if 70% of those probes are having the RTT higher than something, then generate an alert. And that alert can be just put in your existing Itzinga or Nagios monitoring system in very simple way, and then there are more examples and so on. So you don't have to like write anything yourself. You can just like use the power of RIPE Atlas to have an additional alert for your monitoring. Does this make sense?
Yeah.
Do you think it's useful?
I don't want this, so if anyone's interested later, you can ask. I can show.
Okay, cool. If you have time, then measurement ID. Yeah, but you're supposed to replace it. No, like you have to put the actual measurement ID in there. And soon we will give our own workshop, but in the meantime, people from the community have been developing like the tutorial and the training material. You can download it from here. So that was, oh, you wanted the photo? There. Okay, so that was like the general story about RIPE Atlas, and now how do you use RIPE Atlas for IPv6? So this is not even there yet, but I wanted to show it because it's really nice, and it's what the anchor hosts actually looking forward to. So this is a comparison between the performance of anchor measurements, so anchors, over between v4 and v6. So it's a mesh of all the anchors, and then the colors show what is faster. So if it's green, then v6 is faster. If it's red, then v4 is faster, and yellow is like they're about the same. So once we deploy it away from the laptop of the developer, where it now currently sits, is going to be interactive, and on the mouse click it will show you more details and so on. So this is one of the things, so like just showing the difference between v4 and v6 performance. Okay, if you are a member of the RIPE NCC, we have this extra easy visualization for you. So you go to the LI portal, you type in the name of your server or the IP address of your server, and we do the trace route from 1,000 V6 enabled probes around the world that we choose, so random for you, and we show you two graphs that look like this. So the one graph shows the completed paths. So from the probes, which AS numbers were traversed to get to the target that you have specified. And then you can click on each one of those AS numbers and see like who they are and whatever, why did it take so long. The other graph shows the unsuccessful paths. So that's maybe more interesting because then you want to get in contact with them and say, hey, why is the V6 not working between that probe and me? And it doesn't cost you any credits. So you don't have to host the probe, you just go here as an LIR and you do this measurement. So that we developed several years ago for the V6 launch day. This is the academic paper that was presented at the RIPE 68. So they were trying to understand the reachability of prefixes with limited visibility. So, and they made all these graphs and whatever, and then you can, put your own prefixes because they didn't really know like what should they look at and so on. So it's a really nice research project. The next one. Several people were using Atlas, but this was like 3 years ago, for the IPv6 launch day. So they actually did the similar thing, like Wikipedia and like what I just showed here, and then they talked to those providers, and then they changed the providers and improved the performance. So that was really useful for them. And then somebody else was trying to see like, how does it work? Like if you have both V4 and V6 domain name, or V6 only domain name, like what is the success rate? So he did that kind of research. Then for the routing, so people were saying, well, now with V4 running out and so on, the V6 routing will also become more important. Are people already starting to implement the prefix filtering based on the size of the allocation? And some people actually do filter out everything longer than /48, otherwise it would actually like clog their routing table. All kinds of other research, like I don't have time to go through all this and this. And then for the actual operational troubleshooting, now it's a lot of text, but yeah, it looked like a bug, like, oh, this shouldn't even be possible. And then they realized that they just misconfigured something which they wouldn't have found out if they didn't try, to do the impossible measurement. And then this guy again, he was a very active user. He was saying, well, how come that a lot of my IPv6 measurements show like less than what I would expect of the results? Like the results are even worse than what I would expect. And that's because he was using a lot of probes that claimed to have IPv6, but it didn't really work. So then he had to later go through those results and like take them out and like manually deal with that. So he found out that instead of like 100% success or maximal reachability, you can only expect 90%. So this prompted us to develop a new thing that we already deployed it, but I think we will announce next week, is that we do the measurements from all the probes and see if they actually do V6 that day. And then we tag them and then with a tag which says working V6. So then when you want to schedule a measurement from the probes that have V6, we will only give you those. And then, if tomorrow it doesn't work, then we will take the tag away, and then it won't be involved in other measurements later on. So, yeah, these kinds of stories actually help us to improve the system. If you are writing applications about V6, so this is completely unrelated, but it's very important because a lot of people don't have experience. There's all kinds of tips, and the very, very important one, how do you even write the IPv6 addresses? Because now they have letters, so it can be, uppercase, lowercase, a mix, and if you are creating log files with a certain type of V6 address, how do you search for them later on, or whatever, like between applications and so on? So people wrote an RFC and with recommendations, like you should always use lowercase, for example, something like that. So read this before you start writing applications. How am I with time?
You're the last, so don't worry.
Well, I'm standing between you and Rakia. I don't think that's a great place to be. So, time?
9:44.
Okay. So this is, for me, the most important part, all these technical details, yeah. So, how do you fit in here? Well, if you are a programmer and you write some code to analyze your data, please share your code. We have this community repository at GitHub, and people are active, like he is very active. I only do the text edits, and then there are some more people who contribute to it. So there's a lot of things going on there. However, some other people write the software about RIPE Atlas, and they put it in their own repository. So I didn't find a better way to actually link to them than to put them all in a text file called README, and it's here. So, on this RIPE Atlas community contribution, blah, 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 there is another file which is called README, and there is a link to another 10 software repositories somewhere on GitHub that people contributed but didn't put it here. Okay? This is where we also published the source code. And yesterday on Twitter there was somebody who wrote something in Ruby on whatever for RIPE Atlas. So people do share their code. So please help out and publish your code too. Okay, if you are a frequent flyer and you would like to help us distribute the probes in the more exotic locations, which is Eastern Europe, then we will give you some probes. You will be an ambassador, even get a t-shirt, and you can get to the mailing list. We will give you slides if you want to do this kind of talk or different kind of talk. We will give you more material. And we will be very grateful to you, because then you help us cover the areas where we don't have enough probes. If you work for a company that has a lot of money and wants to financially help the project, you can become a sponsor, and then you will also get extra probes, and we are going to promote your company at presentations like this. These are the sponsors that we had this year, and these are the sponsors from previous years. Photo opportunity. And this is how you can get in touch with us. So we have a mailing list. There is a lot of articles being written about Atlas on the RIPE Labs, and contact details. So that was it. However, there is more. I won't go there. So, questions?
How many V1 and V2 probes do you see there?
We don't really have them anymore, like to distribute.
No, I mean...
Plugged in. They're still all there. It's just that like some percentage of them are disconnected and abandoned, but not many of them broke. So we didn't really hear about them breaking yet. So there is still like 500 V1 and probably 2,000 V2.
Is there a way to get all of the data? And how much is all of the data?
No, it's not physically possible. We have Hadoop backend which stores all the data, and it's not even possible to get like all the data for one day, because it's just like we are thinking, how can we even publish that, like with torrents or whatever, like I mean, if we would want to give it to you, it's just not possible.
It used to be that Twitter had this fire calls, they call it the fire calls,
Okay.
so you can get all the tweets that come out.
Okay.
And, you know, in real time.
Yeah.
So it is possible. The question is, are the researchers out there that are interested in all the measurements?
Possibly, but yeah, there are some that would like it, but yeah, we can talk about it later. And one of our engineers is going to be on OpenFest in Sofia, and he will talk about backends and how much data and how many servers and all of that. Yeah, there. And Anand is here too.
I'm also from the RIPE Institute, colleague of Vesna.
Can you shout?
I'm also from the RIPE Institute, colleague of Vesna, and we are thinking of ways of publishing these results in near real time and providing some kind of feed. So you can subscribe and say, okay, I'm interested in this, and this, and you know, we just give you the raw data, and you can go play with it as you like. You know, and one of our engineers, again, the same guy who's going to OpenFest, is playing around with visualizing some of this data into, you know, all kinds of fancy things. So it's in conceptual stage at the moment. It requires a lot of resources from our side, and we don't want to overwhelm our systems. So we have to also be careful about how much we give away. You know, otherwise people will just flood.
Just charge them, you know, just charge them Apple's credits.
Yeah.
Yeah,
That's a good point. Yeah. Yeah.
Okay, excellent. So yeah, talk to me later if you're interested in that kind of stuff.
I have a question.
Wait, there was a question over there.
Yeah. IPv6 and devices like printers and mobile phones and stuff like that. How do we stand for the devices now?
Yeah, a lot of vendors have IPv6 on the box of the device, and it says like supports IPv6, especially the Internet of Things devices. And then when you actually try to work with it, it doesn't work. It's another colleague of mine who is very active in trying to do all these things at home, and then she travels around and gives talks at conferences like in which ways it failed and how much money did she spend on like buying those things, the like, light bulbs that claim to have IPv6, and then they don't, and then she has to ship them back, and like it's just very complicated, not technically, but like, you know, marketing wise. So yeah, I actually don't know about the printers, but I can point you out to her presentation. And we also had IPv6 CPU, customer premises device, CPU something, CP survey, in which we were actually getting information from people to say like which one of these supports what of IPv6, and we were maintaining that for a while on RIPE Labs. I think it's still there, maybe it's a little bit outdated, but it is probably a good help. So it was more about like the home router that can actually do IPv6 rather than the end user equipment.
So you showed that the visualization available only to layers that you can track if you cannot from one layer you cannot see the others, stuff like that. Is it possible that you can publish this data publicly so you can shame these people because they break the IPv6 internet at least twice a month? That's very visible, by the way, in the NTP project, because there's a central monitoring station. Stop seeing a lot of the servers.
Yeah.
So can you publish that somewhere so we can show that to people and say you broke the internet again?
Okay, so there are two sides to that answer. So one of them is that all the RIPE Atlas measurement data, most of the RIPE Atlas measurement data is public. So it's already there, it's just a bit difficult to find. So you can look for all the IPv6 measurements and then like do analysis and like, or pay some student or something to actually show you that. So on one hand that data exists. On the naming and shaming, I can do that here because, it's a small conference and I removed the names and, it was like people that are friends and so on. But for example, for this, for IPv6 ripeness, we cannot, or we decided not to, publish the names of people who are in this area. So people who have no IPv6. Like you can make that deduction because we have a list of all the LIRs in Serbia, and then we have a list of 13, how many? 13 LIRs that have 4 stars, so all the other ones don't have 4 stars. But we cannot like put one list and say this and this and this have 0 IPv6 because it wouldn't look so nice from the PR perspective, but you can. So the data is public, and the way how we represent data is currently we are choosing to only show the good guys. So we show people who have 5 stars, we show people who have 4 stars, but we don't show the people who have 0 or who are actually breaking things. And yeah, our data is used by other people. So the other thing that I wanted to show is maybe a little bit of RipeStat. How many of you have ever heard of RipeStat? Okay, the same.
Probably work years or something.
Yeah. Okay, so that's like also very interesting to discover all this information, because like it's a lot of information out there, and how do you even see it? So we have created one interface for all of it. So it's called stat.ripe.net, and this is how it looks like. And this is the like a portal to the routing information that we collect through RIS, Routing Information Service, our reverse DNS data, Atlas, RIPE database, everything. So this is, so when you query for something, this is what you get. So this is our AS number, and it shows you few things first, and then there's the routing tab, which has another 9 widgets, and then DNS tab, anti-abuse, database, geographical, and then activity.